Hey guys, it's Mr. Rysz, and I'm going to help you with activity 113, the second day of it. So we got part 3 and part 4 to do. You can see here part 3 is a quiz, so we'll take that, and part 4 is a submittable. It's all on here, so you guys don't have to jump around too much. But let's do with 113 here. All right, and I'm just going to go ahead and preview that. You guys will just take it. All right, so what we're going to look at here is called the modulus operator. So what if you want to vary the colors in your flowers so that even number petals have one color and the odd number petals have another? Your program would need to determine whether the petal count was odd or even. To do this, the programming language calculates the remainder of the division using the 2 as the divisor. Even numbers have a remainder of 0, odd numbers have a remainder of 1. All right, in Python, you calculate the remainder of the division with the modulus operator, which is the percent sign. For example, say you have the number num. The construct num modulo 2 will calculate the remainder of the divisor. So you can see here we got remainder equals num modulo 2. The value of the remainder will be 0 if num is an even number. So anything, 8 modulo 2 is 0, 10 modulo 2 is 0, 11 modulo 2 is 1. So the remainder will be 1 if the num is an odd number, or if the remainder is 1. So you can then program different behaviors based on the information, such as drawing rings of petals in different colors. So observe and use the modulus operator in the following program. So let's just observe this. Let's see, we got while I equals 0, while I is less than 10, the remainder equals I divide or modulo 2, print remainder. So we're going to see what it is. We'll run this. And what this did real quick, we did this 10 times, right? Because it starts at 0 and we start at 10. 0, 1, 0, 1, 0, 1. So it goes through, we start out with 0. 0 modulo 2 has 0 remainder. So we get that. Now let's kind of mess around with this. Let's divide by 3 and run. So we start out with 0, 1, 2, and then when we divide by 3, 3 does divide by 3, there's no remainder. Next number will be 4. 4 has a remainder of 1. 5 has a remainder of 2. 6 doesn't have any remainders. 7 has a 1 remainder, 7, 2. So hopefully that kind of helps you figure this out. So the modulo operator performs division and returns the remainder of the division with the program then prints. Replace the prints, 1 second, Bowie. Replace the print statement above with the following lines of code before running and predict. All right, so we're gonna put, here we go, copy that in. And before the print statement, or we probably can put even after. Oh, so let's see. It would have to see if we check to see if the remainder is even. Let's run this. Let me see, the number is even. Oh, gotta go back to 2. Every time we get a 0, we get the numbers even. All right, so according to this modulo operator, is 0 odd or even? Well, mathematically speaking, it's neither, but according to this one here, 0 has a 0 remainder, so it is even. All right, here's the connection. We'll use remainders to help us figure out what time it will be. For example, if it's 1 p.m., what time will it be from 13 hours from now? The answer can be described as 1 plus 13 modulo 12, which evaluates 2. Okay, the version of the flower program uses the modulo operator using that symbol to alternate the colors of the petals. So we look at this here around line 12. So we got the petals. We're going to move forward. We're going to color it dark orchid. And if the remainder of the petals, we're going to find the remainder. If it is remainder, we're going to change the color to blue. So if it isn't, it's going to stay the dark orchid. If the remainder is 2, it's going to go from dark orchid to blue. So if we run this here, you can see we start out in the orchid and then blue, then orchid, blue, orchid, blue. Okay. So in this code, the modulus operator is used to get the remainder of the petals divided by 2. The algorithm then uses its statement to compare to see the remainder is equal to 2, indicating an even number. You will learn about the if statements later in the course. So recreate the program in VS Code and run it to the new flower. Carefully observe the flower and change the 0 to 1. All right, so if we change this, we don't have to put it in our code. We can just edit up here. This is why. Let's change remainder to 1. How is this going to change our picture here? We'll run it again. All it did was switch blues to purples. I'll go back. So if you look here, purple, then blue is the top. If I go back to 0 and run it again, blue, and then purple. So just switches them around. All right, so change the equal sign to a single equal. What happens? All right, so we'll change that to a single equal, and what happens? An error. Okay, so one big mistake a lot of people make, especially when they're thinking about what's going on and not typing it, is the equal sign is an operator to check for equality, while the single equal sign is the operator that assigns a value. So you can never have like an if statement or a while loop or anything like that with just a single equal. All right, so let's experiment with the module and using different operators and values until you're more comfortable with this. So I think we kind of did that above, but mess around with it. Modify the algorithm so that in addition to every other petal of code, every fourth petal changes to a new color. All right, what code would we have to change? All right, so let's see, let's go back. So every fourth. So if the remainder here is equal to 0, so let's see, what we could do is divide by 4, right? And then what we can do, okay, if the remainder equals 0, or do we want to divide by 2? We'll divide by 2. If the remainder equals 2, that works out. So then what we need to do is get like another remainder, right? I'm trying to think here. Or what we can do here is let's divide by 4. So let's think, if we're thinking about even numbers, if we're dividing by 4, and in fact, I'll go all the way back up here to kind of look at what 4 would do. Let's get rid of this part here, this print. All right, we got 0, 1, 2, 3, and then here's number 4, 5, 6, 7, 8. So what we can do is to make anything that starts with a 0 a certain color, anything that's a 2 be a different color, and then everything else would just be the same. So is that what they wanted, or did they just want the fourth color? Oh, addition to every fourth is a new color. Okay, so let's divide by 4, and we can say like if the remainder is equal to 0, we'll make the color, I don't know, orange. And then what we also would have to do is to check to see, and this could be nested in, or we'll just make another separate if. If the remainder was equal to 2, we can make it blue. So we'll run this. So it starts out, oh, but every fourth one, 1, 2, 3, 4, pretty good. It kind of messes up at the beginning too, because I think I start out with 0, but yeah, it works. Okay, so what we had to do was double check and add some things to it. So make sure you guys submit that, and we'll move on to the next part. Hey, Bowie, can you stop the drum, please? All right, so to end part 4 here, what we're going to do is, if I believe this here, yeah, it says right here, we're going to complete steps 19 through 21, but we'll only submit after we get done with step 21. So I might submit it through this module here. So as seen, here we go, we got Tyler modulus. As you've seen, the common use of modulus operators to determine whether the number is even or odd or even. It can also be determined whether conditions such as proportions of a repeating number. For example, assume an architect hired you to design a tall tower and wants every third floor to alternate colors. As shown in the towers below, floors 0, 1, and 2 are gray, 3, 4, 5 are blue, 6, 7, 8 are gray, and so on. How can you think of the modulus operator might be used in a program to sketch this design? Okay, the programmer below draws a tower for each floor where the floor is lined. So we're going to construct that here. So if we look at, let's draw this out, and that is just gray the entire time. Okay. So let's go through this first step here. We're going to create the program here and an algorithm that uses modulo so that instead of drawing tower gray, it alternates colors every 3 floors. Okay, so a lot of different ways to do this, and there's a little hint here too. Remainder floor modulo 6. Okay, so let's do that. Let's find a modulo. So floor equals floor plus 1. So before we do that, okay. Let's do it right here. So let's say the remainder equals floor modulo 6. Because we're going to divide by 6. So really it's going to follow a pattern. 1, 2, 3 are the same. 4, 5, 6 are different. So if the remainder is less than 2, meaning if it's 0, 1, 2, it's all going to be the same. And then if it has a remainder of 3, 4, 5, it's going to be something different. If the remainder modulo 2, we're going to make painter.color blue. All right, so let's check this out, see how that works. Ooh, okay, so that starts out blue. So maybe let's switch this around. Actually, no, we want to switch this symbol around. So let's see if it's greater than 2. Might have had to do greater than or equal to. All right, so we start out gray, then blue. So that's what we had to do here. We had to change that to a greater than something. So we got 0, 1, 2, and then greater than. Okay, 3, 4, 5 works. And then here we go. Okay, so the architect thought your design was great, but discovered the tower is too tall for the site where they want to build on. Each building must be no taller than 21 floors. You propose making 3 smaller towers, still alternating colors, even between each building. The end result is similar to a checkerboard. You can modify your code to the loop to create 3 separate towers, still alternating the colors every 3rd row. The VS can use a new module calculation to see if the if statement to start a new building. Okay, so let's go through that. Let's make 3 of them, and they want us to alternate. So let's just kind of move this over here. Let's start again. So I'm almost going to copy Bowie. Please don't hit that drum anymore. I'm gonna take all the code to make 1 tower. I'm gonna print it off, but this next time I'm gonna make the starting locations. Let's make it at 0, 0. Oh, no, it's at 50. Let's do 0. I don't know why that did. Okay, let's run this, see what happens if I just move it over. Does it make another one? Oh, that's really tall. Oh, it even taller. Okay, I definitely didn't want to do 0, 0. I wanted to change the x to 0, but I still wanted to make the y negative 150. And they say that these are too tall. Well, they're moving. Well, no, they want them shorter, but we'll just leave them. Okay, so there we go. That's the 2nd tower. And you know what? I'm going to put a 3rd tower here. That's tower 2, right? I'm going to do the same thing here. Control C. Copy that over. But I'm going to make this tower 3. And I'm just going to change the x to positive 150. Oh, that's too much. That's, yeah. Okay, let's run this. Let's see if we get 3 towers here. We are. Probably should open this up in Ripple, but. Okay, but they did say they wanted to alternate like a checkerboard. So this one should be blue, then gray. So tower 2 code, I'm going to change it to start out with blue, switch to gray. No, these are too tall. We probably should also alternate, but my biggest thing is, can you guys focus on the modulo? Okay. There we go. Now we got a checkerboard. We could move these closer. Should we move them closer? I think I will. Let's see. We'll make tower 2 at they're all at negative 150, so negative like 75, and then we'll make this one go to 0. Put the distance up. Okay, while that's running, I think that's going to be fine. The architects are thrilled with your sketches and want to add even more color design. Add a third color to your building scheme so that each building has 3 colors using the same every 3 floor pattern. Okay, so let's stick with 6 because 6 is nice because instead of doing 3 and 3, we can do 2, 2, and 2. All right, so let's do that. Let's change this now, 2, 2, and 2. So let's start with just floor or tower 1 here and see. So we're going to divide by 6. Now, if the remainder is less than 2, well, actually, let's do less than. Do we want to do 2 or greater than 2? How about this? We can do like if the remainder is less than or equal to 2, make the color blue. So that would take care of the first ones. And then we can say if the remainder is in between 3 and 4. So if 3 is less than or equal to the remainder, which is less than or equal to 4, it's probably not the best way. We could just set 2 equals to, but painter dot color gold. All right, let's run that, see how that first tower goes. Okay, there are 3 blues instead of, maybe we'll just change that from less than equal to. Okay, so that's going, it's not alternating as well. So let's think about this. Okay, let's just say, maybe we can do this here. We can do and statements. So let's say if the remainder is equal to 0 or the remainder is equal to 1, we're going to make it blue. And I'm almost going to just copy this here. Control C. If the remainder is equal to 2, remainder equals 3. And so that means 4 or 5 would stay gray. All right, that works better. So we got 3 colors here. So I guess they want us to do they still want us to do the checkerboard? It won't take too long here. So I'm going to take this code here that I just made, Control C, and I'm going to go to tower 2 and just add that in right here, Control V. But I just got to double check my colors here. So let's see. I want it to start out, on this one it started out blue, gold, gray, blue, gold, gray. I need to start out gray, gold, blue, maybe. Just shift things now. Gray, blue, gold. Ooh, if I put, ooh, what happened to this one? Tower 2. Sorry, yep, we're just, a lot of trial and error here we're messing up with. Why are there multiple blues here? Remainder, it is switching to gold. Oh, did I not do the, am I not, I'm not even. Yeah, Bo, what's up?
I stayed in the line.
Good job. I wasn't looking at the right code. Okay. That's the problem. Okay. Blue, gray, gold. That was the problem. I wasn't looking at the right section of code. That happens too. And then let's do the third final version of this one here. So I'm going to copy this line of code here. And how should it go? I got, let's see, gold, gray, blue, blue, gray, gold. I should have gray, blue, gold, I think. We'll find out. Gray. Good job, bud.
Dad, I want Fruit Loops.
Fruit Loops. We're just going to check to see if this works, and then we'll be all done here. Looking good, looking good. Is this another different one? No, that one's different. Okay, so there we go. Sorry that took a minute here. A lot of little iterations, probably but better to open this up in Ripple. So hopefully this helped you guys out with this. And if you guys have any questions, make sure you ask or send me emails, but we're going to end this, and this ends 113. Have a great